Hi guys, Dr. B here. This is topic 4.8 and 4.9. 4.8 is Introduction to Acid-Base Reactions. The objective is to be able to identify species as Bronsted-Lowry acid bases, or conjugate acid-base pairs based on proton transfer involving those species. An acid-base reaction is a specific type of reaction in which a proton is transferred from one species, the acid, to another species, the base. It is important not only to be able to identify if a reaction is acid-base reaction, but also be able to identify the acid and base within the reaction itself. By the definition for Bronsted-Lowry, if an substance donates a proton in a reaction, it is considered the acid. Likewise, a substance that accepts the proton is the base. When an acid transfers a proton to a base, the acid becomes a conjugate base. The acid and the conjugate base make a conjugate acid-base pair. When a base accepts a proton from an acid, the base becomes a conjugate acid. The base and conjugate also make a conjugate acid-base pair. They will always differ by one proton. Water is a unique species that it can be either acid or base. By donating a proton becoming hydroxide, or a base by accepting it becoming a hydronium ion, H3O+. Here are some general formulas to keep in mind. So you have an acid plus base, or water, for example. It will form a conjugate acid, H3O+, that's the hydronium ion, and the A-, or the A-, that's the conjugate base. If base is reacting with water, the water will become a conjugate base. So it's an acid, and its base pair is conjugate base is a hydroxide ion. The conjugate acid is the H added onto the B, making it Hb+. Acid and base can differ by strength. A strong acid or base will ionize completely in water, but a weak acid will have less than 100% ionization. For example, hydrochloric acid is a strong base, so that the reaction is shown below, to where you have a single arrow that at the end of the reaction no HCl should remain, and 100% of it becomes hydronium ion and chloride ion. By contrast, if you have a weak acid, you'll have a double arrow, and it indicates that by the end of the reaction some of the acetic acid will remain, because less than 100% of it has become hydronium and acetate ion. It is also important to know that a stronger acid will form a weaker conjugate base. A weaker acid will form a stronger conjugate base. A stronger base will form a weaker conjugate acid, and a weaker base will form a stronger conjugate acid. An acid-base reaction will favor the formation of the weaker acid and base. So you may see some questions that are going to be asking you this, which is going to be the stronger acid, the base, etc., blah, blah, blah. So getting this wrapped around your head will be pretty important. The conjugate of a strong acid or a strong base has no acidic or basic properties. The strong acids are chloric acid, HClO3, hydrobromic acid, HBr, hydrochloric acid, HCl, hydroiodic acid, HI, nitric acid, HNO3, perchloric acid, HClO4, and sulfuric acid, H2SO4. Strong bases are lithium, potassium, rubidium, calcium, strontium, barium, hydroxide. So lithium hydroxide, sodium hydroxide, so LiOH, NaOH, KOH, RbOH, calcium hydroxide, CaOH2, strontium, OH2, BaOH2. So you want to keep those in mind, because these will be 100% ionization, while any other acid will not. So it's considered a weak acid. If it's not one of these acids or bases, it's considered weak. Identify which of the following is an acid-base reaction, then identify the acid-base, conjugate acid, and conjugate base in the reaction. So we have copper plus aluminum ion produces a solid aluminum and copper 2+. We have H2 plus O2 making H2O. We have ammonia plus water produces ammonium ion and hydroxide ion. And then Cu2 plus hydroxide ion forms copper 2 hydroxide. So which of these is considered the acid-base reaction? Excuse me. Then identify blah blah blah. So based on our our notes and all that stuff, the only one that actually is an acid-base reaction is this one right here, number 3. So the acid is going to be the water, because the water is donating a hydrogen over to the ammonium ion. So that makes, if this is my acid, this has to be my base. This is my conjugate acid, because that's the pair with it, and that is my conjugate base. So it kind of pairs up. So whatever, if water lost the H and makes it an acid, then the hydroxide group, the hydroxide ion, will be a conjugate base. And since the ammonia accepts the proton, or the H, from the water, that makes ammonia the base, and ammonium the conjugate acid. We have the nitrite ion plus water produces nitrous acid and hydroxide. Number 1, identify 2 conjugate acid-base pairs in the reaction shown above. So we are looking at, we have a nitrite ion and a water. If you look at the product side, it looks like the water loses an H, I'm sorry. So that makes the nitrite ion and the nitrous acid, that's our base and conjugate acid. So the base acid-base pair is NO2 minus and HNO2. And then the other one is the water and the OH hydroxide ion. It tells you that if nitrite is a stronger base than hydrogen oxalate, then which is the stronger acid, nitrous acid or oxalic acid? Justify your answer. So how would you do that? So it's telling us that NO2 minus is the stronger base than HO2 C2O2 minus. This is a stronger base, weaker base. So how would you, so remember we said that stronger acids tend to produce weaker bases. So that means that HO2C2O2H is a stronger acid. HNO2 is the weaker acid. Well, I can't read that, I'm sorry. So how would you justify your answer? So because weaker bases tend to be made or produced by stronger acids, we can conclude that oxalic acid is the stronger acid of the two. That's how you would justify it. Topic 4.9, oxidation reduction reactions, redox reactions. I don't like the slide. I mean, I like the slide. It's kind of cool, like, PowerPoint and all that, but this annoys me. Not gonna lie. And that one does too. Just saying. Disappointed. So, represent a balanced redox reaction using half reactions. So you will look at the other video that's posted, the 4.9 help video, and that's like the actual practice problems part, or like how to solve problems related to it, like step by step. So interpreting types of redox reactions. Redox is the transfer of electrons from one element to another. Oxidation reaction cannot occur without reduction. One substance must gain the electrons lost by the other substance. All chemical reactions except double replacement and precipitation reactions and neutralization reactions are redox reactions. The substance that undergoes oxidation is called the reducing agent, while the substance that undergoes reduction is the oxidizing agent. This is not really tested on the AP exam, but it's still important to know. or just to be aware of at the very least right now. If you go into organic chemistry in college, and also, general chemistry, you'll have to know that stuff. So, oxidation occurs when an atom undergoes an increase in oxidation number by losing electrons. So oil. Oxidation is losing. Reduction occurs when an atom undergoes a decrease in oxidation number by gaining electrons. So what does that mean? So Leo of the line goes grr, oil rig. Those are just two ways to help remember this. So what's happening is that calcium, like a solid thing of calcium, 0, its oxidation number is 0. It's getting an increase in the oxidation number because it lost electrons, so 0 to 2 plus. So hopefully remember that. Reduction occurs when an atom undergoes a decrease, so you have 2 electrons being added to 0 and makes it 2 1 minus electrons. So the 1 minus, it gained electrons, so it's kind of like the electronegative atom gaining electrons, like that. That's where the reduction occurs. It's a decrease in oxidation number by gaining electrons. So remember that the signs, kind of dictate, like, it kind of doesn't make sense. Like if you're reduced, but you gain electrons, remember you're decreasing, your reduction is in your oxidation number. Oxidation is increasing your oxidation number by losing electrons. Rules for oxidation numbers. An atom is elemental form, oxidation number of 0. Any monatomic ion has the oxidation equal to the charge on the ion. Oxygen in a compound has an oxidation number of -2. Excuse me. Oh, so tired. Exceptions are peroxides, because peroxide is O2 2-, that's a -1 charge. Hydrogen has an oxidation number of 1+. Exceptions are hydrides, so basically when you have a metal with hydrogen coming second as the non-metal, so like calcium hydride, all that, that's where it's -1. It's usually 1+. In binary compounds, the more electronegative is given the oxidation number of its species. Fluorine is always -1. Atoms in groups 1 and 2 are 1+ and 2+. The sum of the oxidation state must equal to the overall charge of the species, whether it's 0 or it's positive or negative. And so these rules we've already gone over before we went to 4.2. So yeah, not too bad. Examples of redox reactions. So we have sodium plus Cl2 makes NaCl. So sodium is 0 and chloride is also 0. So you'll notice that if you put NaCl together, Na is 1+ and Cl is 1-. We know that already. So sodium is changed from 0 to 1+, so it lost an electron, so that's oxidation. The chlorine, the Cl2, went from 0 to -1, it gained an electron, so that is reduction. Decomposition and single replacement, you can see these, review these. So calcium oxide produces calcium and O2. Calcium is 2+ and oxygen is 2- in calcium oxide. So they both go to 0. 2+ becomes 0 for calcium. That means it gained 2 electrons. So that's reduction. Oxygen is -2 and it lost 2 electrons to be 0. So that's going to be oxidation. Single replacement, oxidation of metals by acids and salts. You have zinc and plus HCl making H2 gas and zinc 2 chloride, I'm sorry. Aluminum plus copper 2 chloride makes copper and aluminum chloride. You can use in something called an activity series table to determine if an reaction will occur. If the elemental metal is higher or more reactive than what's replacing, a reaction will occur. The above actions will occur, but the reverse of either will not. So what this means is that there are certain levels of activity, reactivity, so to speak. So if an element is more reactive, so kind of like the sodium and water lab, the sodium kicks off the hydrogen because sodium is more reactive than the hydrogen. Combustion of hydrocarbons, the O and O2. So you have CH4 plus O2 produces CO2 plus H2O. The O and O2 0. The O in both CO2 and H2O has an oxidation number of -2. The C is -4 in methane, the CH4, while the oxidation number of CO2 is 4 plus, so oxidation occurs. You lose 8 electrons. You've already learned the guess and check method for balancing equations. The redox method of balancing equations can be used when there's a transfer of electrons. In order to balance an electron using the redox method, you must assign oxidation numbers to each atom in your reaction. So rules for balancing using the redox method. So there's a standard method. There's a video going to explain how to do it like step by step. I did work it with you, but here's a step-by-step video coming up. So you assign oxidation numbers, you write out the redox half reactions. You can balance the half reactions for atoms, balance the half reactions for charge by adding electrons, make electrons lost equal to the ones gained by multiplying the entire half reaction. You put the coefficients into the reaction, then balance the remaining atoms. Do not change the coefficients for the species involved in the redox. Check to make sure that the total charge is equal on both sides. I feel sleepy. I'm sorry. Woo. Rules for balancing in an acidic solution. It's unlikely you'll have to balance in an acidic or basic medium on the AP exam. It's unlikely, so I won't really cover it per se, like, in lecture, but do your best. Review the slide. But remember that you have to know your oxidation numbers for it to be correct. If you don't know the correct oxidation number, that's going to mess you up, and it's kind of pointless at that point. Okay, so if you have any questions, please let me know. Thanks.